Okay. Somehow they did not assign me the host right. And then in the process, when I got disconnected, I was trying to re-enter, but it was not allowing to re-enter. Anyway, so again, you got a force break in the process. So there is always a right side to it. But anyway, let's just go ahead with our piece. I think Kajal, the last thing which I remember was Kajal had asked some question. And that question was, I think, with regard to this information gain Gini index. So Kajal, if you could again, I'm just allowing Kajal. She's there. Yeah. So Kajal, you might probably raise your question again, and we can sort of discuss. Yeah, Kajal.
No, I was just asking what's the relation between entropy and information gain. So
Okay.
there's a formula in which they have explained how the information gain is calculated by using the entropy of parent minus child or something like that. So if
Sure.
you could explain that.
Why not? Why not? But again, very important concept. Get this clear. So what happens is that initially, when I'm having all the data, I'll give the same example like your performance, the T, because again, that's probably easier for you. Note. So again, there was, so this is my as is original data, right? So let's say there are 100 people, of which 80 did very well, good, and let's say 20 did very poorly. And here I have my different features like LS attendance. That's one of the features, right? Async understanding. That's one of the features. And then things like let's say study time. These are all the different features based on which your performance in the T or the exam, good or poor, that has been tabulated. Now, what's happening is that when all the data is there together at the same point in time, so here you have the 80 good cases and 20 poor cases, which means if I calculate the entropy, that will be minus 80 by 20 log to the base 2 80 by, I'm sorry, 80 by 100 minus 20 by 100 log to the base 2 20 by 100. So that's what the entropy is at the root node. Sorry. Now you are contemplating that whether you are going to split by this LS attendance, async understanding, or let's say study time. Let's say if I split it via the async understanding, async part, if I do the splitting, async understanding good and then bad. Let's say people who understanding should the async part well, good part, right? Let's say 50 of them, they did well, and 10 of them, they did not do that well. People who did the async part poorly, so here the 10 bad, 10 cases of good, and 10 cases of bad, right? So good performance, bad performance, good performance, bad performance. So now I calculate the entropy for this particular section also, the async section. And then let's say LS attendance. That's also another piece where I do LS attendance, yes and no. If the LS attendance was yes of the people who attended, let's say 70 people attended, 60 of them, they did extremely well, and then 10 of them, they did not do that well. LS attendance no, so of which 20 did well, 10 did not do well. So this is my overall tally. Now what I'm going to do is I'm going to have an entropy here also and a entropy here also. If you remember our last discussion, what we discussed was that whenever the entropy is on the lower side, which means it is helping me go to some pure kind of configuration. Whenever the entropy is higher, I'm on an impure configuration. Now, at the end of the day, my requirement is I can get to pure kind of nodes so that I'm able to give a decision. Now, whatever was the entropy here, right? Entropy at the root, whatever it was, if I subtract the entropy of the root minus the entropy of, let's say, the async content one, minus the async of the lsync part. If here the entropy value was very less, this reduction in impurity or the information gain is the highest here. If I calculate the entropy here at the root node and then the entropy out here for the async content, if I calculate the difference in the entropy or the information gain, this also will give me some value. Wherever this value is higher, it means that I've been able to reduce the impurity by the maximum extent. So let's say here entropy was 1. And here, let's say I have got to a situation where the entropy is 0.1, right? Very low. And here, let's say the entropy is 0.3. So when I see the reduction in the impurity, right? The async part, async content part, that particular decision, if I go by with the impurity is right now 0.3. Whereas if I go with the ls part, the impurity is 0.1. So which means the reduction in impurity in the async part is 0.7, while the reduction in impurity in the ls part is 0.9. This particular part is where maximum reduction in impurity has happened. It means that I'll probably choose this particular arm for doing the splitting. I'm able to make myself clear now. Kajal, is it understood? I hope so. Okay. Good. Let's move ahead then. Lots time, right? Okay. So how do we avoid this overfitting part is what we were discussing. See, again, if overfitting is not very good, as I said, that it just memorizes the data points and it's not able to do a very good thing. So there are many different ways in which we can avoid the overfitting. One is that you probably say that I would like my tree to give me, let's say, indicative, let's say 90% accuracy. Once it reaches a 90% accuracy, I'm not bothered that whether this tree is giving me better accuracy at some level or not. I'm not bothered. My performance is 90%. As whenever I'm hitting that, I'll stop growing my tree. That is one way of avoiding overfitting. Right? You predetermine that this is where I'm going to stop at a particular performance threshold. Or sometimes what you can do is that, okay, I don't want very complicated decision tree. Right? Decision tree mat might go into 100 levels, but I'll maximum grow this tree only to the third or the fourth level. Beyond that, I'll not even look into it. That's also another way you can avoid the overfitting. Another method is something called post-pruning. So what happens the post-pruning is that you let the decision tree fully grow. Completely it grows. And then what you try to do is that you retract backward. Okay, I have grown the decision tree fully. And a fully grown decision tree, generally, the performance on the training data will be 100%. 100% accuracy you get on the training data. But then what you're doing is that you're also looking to the validation data. And you're seeing that, okay, if I have the tree up to the full level, what is my performance validation data? And then probably you'll prune it that, okay, fine, I'll the last one. What's my performance right now? I'll prune this one again. What's my performance right now? So like this, you probably try to prune the tree and find out that where you are getting the optimal performance on the validation data or the test data. And that is how you will avoid the. Anyway, I have a Python this thing to show you, worked out example to show you. We'll show that in much detail. Okay, so decision tree, there is also things called hyperparameters. So things like the split criteria, that how you're splitting, entropy, Gini index, all those things. are the split criteria for the decision tree. Depending on what metric are you using, entropy, Gini index, chi-square, classification error, the values will change. Other one is the maximum depth part. What is the maximum depth? Am I going to keep it at 1, 2, 3, 40, 100? What's the maximum depth? So depending on the depth part, as I just discussed with you, here also the decision tree. And also there are some other hyperparameters which are saying that the minimum sample split. Minimum sample split says that, okay, before I would like to split a particular node, this many number of samples should be minimum there. So let's say that I've said that if my number of samples are at least, let's say 20, then I'm going to split the particular node. Otherwise not. I don't mind, I don't bother that what is the performance right now. If it's less than 20, I am not going to split this particular node. That's the minimum sample split. And the other one, which is very closely related to the minimum sample leaf. Leaf is nothing but the terminal nodes of the decision. Saying that my leaf nodes are going to have minimum, let's say, 10 data point. So we will try to ensure that the leaf nodes are at least having 10 data points and not beyond that. So let me give you an example. Let's say that you have put the minimum sample split as 20 and the minimum sample leaf as, let's say, 8. So now after doing a split of this particular node, let's say this 20 node has been, minimum sample split is 20, right? So let's say our node is having 22 records. It is satisfying the minimum sample split, right? It is more than 20, so you can split it. After doing the splitting, let's say on one of the nodes you are getting 9 and in one of the nodes you are getting 13. This satisfies both the minimum sample split as well as the minimum sample leaf. This one is valid. But then let's say the split was something different. So here you have 15 here and 7 here. 15 plus 7 is 20. In this particular case, the minimum sample split is okay, but the minimum sample leaf you had said should be 8 out here. So this one, though it is satisfying the minimum sample leaf part, this one is not satisfying the minimum sample leaf part. Minimum sample leaf has been marked as 8 and here you have got 7. Then this particular split will be invalid and overall this particular node you will not be able to split because of the conditions which has been put in of the minimum sample split and the minimum. I hope you got the point. Right? Okay, let's go ahead. Here are an example which specifies what we tried to say right now. Okay. So maximum depth of the decision tree, right? What depth the decision tree should go. As I said that if you're having a decision tree which a very large value, not very healthy one. This is something that you have to tune. And for tuning, one of the popular methods is something called as a cross-validation or CV. Right? Cross-validation part will talk in details, more details into the model building part, model selection part. We'll talk into it. But again, just let me do the regression tree and then I'll show you a hands-on example. Many of the concepts will get cleared when we do that hands-on part. Right? Okay. Let me quickly say minimum samples for node split. I think I've already discussed this. Minimum samples for terminal nodes. We've all discussed this. So whatever I've discussed, it's just explain more details out here. Once you read this, I'm pretty sure that you'll be able to understand that part. Full extraction from decision tree. That's also something that we had discussed in the last class. That whenever you have grown the tree, a particular level whatsoever, depending on how the tree is being built, logically you put in various AND condition and you find out how the decision tree has been. Okay, so let me take you to the part of issues in decision tree, and then we'll jump to the regression. See, one of the issues in decision tree is handling continuous attributes. You might ask that, Professor, you have already said that decision tree can handle continuous variable. Yes, it can handle variable, but how continuous variables are interpreted is by several classes. So let's say that in a class, the marks goes from, let's say, 0 to 100. Now, whether to split at 1, 2, 3, or let's say 67, I don't know. Right? So internally, what it does is that it actually creates several different categories. Marks less than 20, marks 20 to 40, 40 to 60, 60 to 80, 80 to 100. Like this, it creates different classes. Right? That's what happens internally. Right? But again, this process keeps on happening many times. This continuous attribute, if it's there, what happens is the optimization or the cutoff for the continuous attribute, it takes time for the decision to find that out. So it can handle this continuous attribute, but it probably deals with it in a very inefficient manner. Right? Like again, handling things like data with missing attributes, though decision tree is robust, cases where the missing values are there, still, if in a node which has been found out to be significant, be important for splitting, there are missing values out there, so obviously is going to have issue with that. Appropriate attribute selection measure. Should I use entropy? Should I use index? Should I use chi-square? There is no direct thumb rule for that. The only thing which I can tell you is that of the three methods which we have discussed, the entropy, the Gini index, the classification error, of which entropy is probably the best method from the information science point of view, computer science point of view. The chi-square value, it comes from the statistics. That's also measured from the probabilistic point of view. Computationally, decision tree is pretty inefficient. It takes quite some time to build the decision. You'll see that just going ahead. Right? Okay. So from classification, let's jump to regression. Find that this is the same kind of example that we have done earlier, with a difference that earlier you had that whether people are going out to play, let's say, golf or not. Right? Play, not play. The number of players on the field, number of players on the field. And right now, what you need to find out is how you can find out the best decision tree, which can help you predict the number of golf players on the field. The good news is that the method which we used for doing our classification tree, we can use almost the same logic out here for the regression tree as well. Our entire focus in the classification tree was to reduce the impurity of the decision tree, right? If you remember, was to reduce the impurity. And this is something that we are going to do for this regression as well. Question to a class, just a common sense, common logic is that how can I measure the impurity of some continuous numbers? How can I measure the impurity of some numerical variable, continuous numbers, what we are seeing? How can we measure the impurity of that? Answers that come in. Okay, so Grani Kumar is saying outliers. Okay, how can I measure the impurity? Right, outliers is not the answer. I can definitely tell you. How can I measure the impurity of some numbers? Right, when are a set of number pure versus impure? Raju has given us the answer. Variance, yes. So let's say if you have a set of numbers, right? Let's say I'm looking at your scores, and all of you have got out of 100, all of you have got, let's say, 90. Everyone has got 90, 90, 90, 90, 90. Right? So which means your scores, your performance is continuously pure. There's no deviation in your scores, in your performance. Absolutely pure. But let's say someone has got 100, someone has got 90, 70, someone has got 50, 40, someone has got 80. Then there's a right. What we'll try to do a regression tree is we are going to reduce the variance of the regression. That's what we are going to attempt. Let me this particular part. Let me show you how we are going to do it. Now it is continuous, as our good friend Munraju said, that we will try to look into the variance of the decision. So this is my root node. So at the root node, this is what I am getting as the average divided by the total number. And this is what I'm getting as the standard deviation. I could have used the variance also. Here we are taking the standard deviation. So 9.3 is the standard deviation in the number of golf players in the field at the root. Again, here I need to do the decision tree. What I'll do is first, like we have done before, we will select the various attributes and see that on which attribute I am able to do a good split. Right? So let's look at the outlook part. The outlook can be sunny, overcast, and rain. So let's calculate the variance, or again the standard deviation, whatever you want to do for all these outlook candidates. So let me show you the data. This is how the outlook looks like. Right? So outlook sunny. So here you see that sunny is something which I have fixed. Outlook sunny is the standard deviation 7.78. Outlook overcast, this is the standard deviation which I'm getting 0.49. And then outlook rain, this is the standard deviation which I'm getting 10.87. Now what I need to do is I need to find out the pooled standard deviation for the outlook variable. So if you remember, there were 14 data points in total, so of which 5 are there for the rain. So 10 by 87, 5 of them they're coming from the rain, 4 of them they're coming from the overcast, and 5 again from the sunny. So if I do this, this is what I get: overcast 4, rain 5, sunny 5. So this is my weighted standard deviation 7.6. Initially, if you remember, at the root node, the standard deviation was 9.32. If I split it based on this outlook, the reduction in standard deviation is by 1.6. I can do this for the other variables as well. Let's look at the temperature. So for the standard deviation, temperature, so standard deviation of the temperature part is 8.84. So reduction in the standard deviation is 0.47. So just to show you, here for the outlook, the standard deviation was lesser, which means this is more pure compared to the standard deviation 8.84 out here. Similarly, I'll split based on the humidity. Humidity high, humidity normal, 7 instances each. See the standard deviation 9.0. Reduction in impurity, reduction in the variance, standard deviation is 0. That's what we have out. Now, if I look at the wind, for wind it is 0.9. That's what we are getting. Now, if we tabulate this, what we have for outlook, the reduction was 1.66. For temperature, it was 0.47. Humidity is 0.27. Wind is 0.29. My question to the class is that which particular feature I would use to make my split based on whatever you understood. Please, I would like to have the answer from everyone. Which particular feature do you think you'll be using for doing the splitting. Right? If you have understood, I think all of you can answer. Right? So yeah, Nisha is saying Outlook, Dinesh is saying Outlook, Deepak is saying Outlook, right? Anyone else with a different thought that why it's not going to be Outlook or anything else? So the answer is indeed Outlook, because the Outlook variable, when we saw that it had the least standard deviation amongst all the other variables, temperature, humidity, wind, all the other features, Outlook had the minimum variance or standard deviation which was there, and the reduction in the standard deviation at the root this particular branch is the maximum when we use Outlook. That is going to be my first variable, first feature for doing the splitting. So Outlook sunny, Outlook overcast, Outlook rain. This is where I am right now. Right? What I am at right now. Now the next step would be to make sure that I am able to reduce this thing by further. So let's take as the sunny outlook. So sunny outlook, this is the standard deviation, 7.78. I have to split the sunny outlook right now in such a way that I am able to reduce this overall standard deviation. Once again, I go through the same process, right? Hot, cool, mild. These are the instances. 1, 2, the instances. So for the sunny outlook, reduction in standard deviation, temperature, humidity, wind. Once again, my question to the class is that which particular variable right now you are going to use for splitting the sunny? Which particular feature you are going to use for splitting the sunny outlook? Now that we have the reduction in standard deviation, which has been already shown to you, which is the one which you are going to use? Yeah, anyone? Quickly. Once again, temperature, great. This is giving me the maximum reduction. So here, if I split by temperature, I'm probably going to a part where I'm reducing the standard deviation more and more, 0.18. Okay, my outlook sunny, I have split via this temperature part. So temperature cool, temperature hot, and temperature mild. See here, I'm left with only one record. Two record. And because it is a numeric variable, right? Chances are very few that, okay, I mean, for all the different conditions, values are going to be the same. Very, very few chances that, okay, both will probably be having a value of 30, both of the cases, 35, both the cases. Again, when we further split this, again, we will be left with one record in the terminal nodes, not a thing. So for splitting a regression tree, here are some of the hypertuning parameters. If there are less than 5 rows of data in a particular node, don't split it further. Standard deviation is less than standard deviation of the less than 5% of the initial standard deviation, don't split it further. Don't clone it, this will result into kind of over. And how you're going to use this tree for making prediction? Very simple. That I'll just take the average value in a particular node. So let's say this outlook overcast. If I go back, outlook overcast. So whatever is the number out here, mean or average of that is being used for predicting the case when the outlook is overcast. The mean or the average of this predicting the sunny cases. Like this, we are going. Here for the overcast case, you're seeing that already there are 4 records, which is less than 5. Probably will not split it further. So yeah. This is the prediction for the outlook overcast. Prediction for the outlook sunny. We split it by temperature cool, hot, mild. So these are the predictions. If it's rainy, we split by the wind, weak, strong, hard. That's the final regression tree that we have arrived at. Right? Doubts, questions? If you have understood this, again, the same logic, if I apply in the classification one also, the same thing, reduction, purity, and all those parts. Good. I'll be right. Okay. Let's probably try to do a hands-on the decision tree part. Okay. This is the summary which is there. There are supervised learning algorithm, as you have seen, and how they differ. It's mainly by the splitting criteria that we use. It can solve both classification problem as well as the regression problem. Right? So the several techniques that we have talked about in the class there. Just go through and revise slides once again. I'm sure now, right now, things will make much more sense when you're reading. So here is one of the practice question which is there. Here, try to solve this at your leisure. Right? Let me go to a hands-on part for the decision tree. Here I'm going to use a regression tree for the solving part. I hope by this time you have already downloaded the data set which has been given to you. They downloaded the data set already. Yeah, download it. Yes, no, maybe. Please download the data set as well as the Python file which I have shared with you. Right? So yeah, please download that if you have already not downloaded it. What we are going to do is we are going to use that, discuss whatever we have learned in the class till now. We are going to show that live, the example that we are going to have. So for the example, you have this data set for the 50 startups which are there. Okay. So let me open the data set for all of you. Just tell me if you're able to see my screen. Okay. Able to see my screen? Okay. Simant is saying that it's not shared. Is everyone facing the same issue? I think I'd shared it. I had given you the link also. I am just giving the link once again. Please download this file from this particular part. Okay, thank you, Deepak. Thank you, Deepak. So this is the data which I'm having. So here it's a regression problem where based on the R&D spend, administrative spends, marketing spends, and the state where the startup is listed, the various profits of the startup are tabulated. Right? What has been given to us? What we need to do is we need to create a regression tree from this, predict the profitability of the startup. That's what we are going to do. Let me show you Python file. I'll go step by step on the Python file. Everyone, please try to follow. We might not get another chance to show an example in details. Right? The first thing is that, see, my file is there in the Google Colab. First thing is that I am mounting my particular drive. And in my drive, within contents, my drive, collab notebooks, and data set. This is where my files are stored. These are the different places where the files are stored. As you can see, this 50 startups, it's there in my file list. I'll use this 50 startups to solve my problem. Okay, so Bharan is asking file to be opened in Jupyter or Orange. It's okay, good. All the people who are having Orange, please keep the Orange ready. Let me explain it to you in Python. We'll also do the same thing in Orange as well. We are going to do the same thing in Orange as well, right? Okay. And as of now, let me just explain it to you in Python. So now I want to read the particular data file for which I have this pandas, which is the library which helps us read data files into DataFrame. So I've imported pandas as PD. So pd.read_CSV. The CSV file is there. So the file path I have given, the file path is already given, and the name of the file, 50 startups. Let me read this, and if I do a DataFrame.head, this is the different columns and the profit. The first 5 columns are given when we say DataFrame.head. If you do a DataFrame.tail, it will give you the last 5 columns from the particular file. Last 5 rows from that particular file. Right? Fair enough? So now that my data file is already there in my system, let's do one thing. Let's look into the shape of this particular part. So the shape says that there are 50 rows and 5 columns, and the 5 columns are R&D spend, administration, marketing spend, state, and the profit. Right? Data frame dot columns is going to give me whatever columns are there in the data. Once again for you, these are the different columns which I'm having. If I do a data frame dot tail, as I told you, that the last 5 rows, it's showing. Quick question to the class. I had 50 records. Why it's showing 49? Why it's showing 49? Quick question. Anyone? Why it's showing up to 49? I've given a data frame dot tail. Show me all the 50. Why up to 49 it's showing? Jaya has given that. Very good, Jaya. Row 1 is indexed as 0. Good. If you remember, here it started from 0. So 0 to 4, first 5 rows. So obviously 45 to 49, last 5 rows. Okay. So Deepak, that's not the answer. And the answer which Jaya gave, that row 1 is indexed as 0. That's the answer. Right? Let's move ahead. So let me get the data types for this. So these are the different data types that I have. Floating value, which means numeric value, float, numeric, marketing spend, float, numeric, object, which means categorical values, and float, which is numerical once again. If I do a data frame dot describe, this is what it is. Right? Count for all of them is 50, mean value, standard deviation, minimum value, right? So you can see that for R&D spend and for marketing spend, the minimum value is 0. So which means that there are companies which just does some administrative task without having anything to do in the R&D and in the marketing spend out there, right? So that's what we see out here. The maximum R&D spend which a company made was 165,349. The maximum marketing spend which a company made was 471,784. Right? If I look into the mean values, right, in the mean value part, what we see is that generally company makes pretty high marketing scores, marketing spend. That's what we see. Again, these are different summary that we get from it. Right? Okay. If I do a DataFrame.info, showing me that there are 50 entries 0 to 49. All of them, they have non-null values. So I told you in the very beginning that I'm going to give you a data set which is recently cleaned so that we won't have to spend time on cleaning it. So yeah, here is what we have. Right. So now that let's go ahead and do the modeling part. So yeah, quickly, just to verify, there are no null values in the data set. Right? That's one thing. And what I'm also doing is my state variable, I'm making it as a categorical one from a object variable. If I do once again a model data.info, you'll find that from the object, this particular state has been put to a category. So I'm good now. And then let's move ahead. Let's move ahead. Here, this is a regression problem. This is a regression problem. My target variable is the profit variable. So my target is the profit, and the feature variable is everything apart from profit. So that's why I'm putting my target as the model data within which the profit column is my target variable. And for the feature variables from my model data, I'm just dropping the column profit. All those are the features, while profit is the right. Now, if I look into the features, these are all the, sorry, I have to run this. These are all the features that I have, right? R&D spend, administration, marketing spend, and then this state, right? So now I have segregated my feature and the target. It is time to create my training and testing set, as I had showed you in that diagram which was there, right? So I'll split the data into 80% training and 20% validation set. So Y variable, I'm saying that is take all the values from my target. X variable, take all the values from my features. Then what I'm doing is from sklearn. So that's the library. There is a model selection library also, sub-library within sklearn module. I'm importing the train test split and giving it an acronym as TTS. And then to this TTS, I'm passing my features and my target. And I'm saying that my train size is going to be 80%. So if I run this, it has already created the training and the validation for me. Now, I'm running this. So from decision tree, I've imported the decision tree regressor. I've created a model which is nothing but an instance of that decision tree regressor. And then I'm fitting the model on my train data. X train, Y train, I'm fitting it on that. See that there is some kind of an error which it has given. If I go into the error, it says could not convert string to float, California. By the way, what exactly is this particular value California? Where is it coming from? Anyone? Any idea? Where is this particular value California coming from? From the state variable, right? It's coming from the state variable. So here, my state variable is still a string. It's not able to handle that. We have to do a little data pre-processing out here. So what I'm going to do once again is that I am just going to do a splitting, but this time I'm saying that dummify my data. Right? Then now, if I do a x.head, R&D spend, administration, marketing spend, but the state variable right now, state Florida, state New York. That's what it has created. Where did California go, by the way? Why California is not here? Why California is not here? ML1, why California is not here? Why California is not here? Dinesh is saying -1. Again, I'm a layman. I don't understand what is -1. Why California is not here? Should have been there. Should have been there. Why it's not there? Jaya has given us the answer. California is represented by 0. That's the default one. So here we have not done a one-hot encoding. We have done a dummification and we have dropped the first particular column. Kaushik has also given the answer. If they're in categories, so here we actually had 3 categories. In the state variable, if you open your Excel sheet, you'll find that Florida, New York, and California. These 3 were only there. And for representing these 3 categories, 2 variables are sufficient. So that's why Florida and New York, that has been here. Good. Very good. So once again, I'm going through the process of doing a train test split. X train, X valid, Y train, Y valid is what it will return me back. And I'm putting the values of X and Y. So if I do this, right, I already have my X train, X valid, Y train, Y valid being coming created by this train test split. Once again, I import the decision tree regressor module and create a model which is an instance of the decision tree regressor. So let me do this and then let me do this. So now I'll fit my training data. So my training data, train, X train, Y train. So my X value and the Y value feature and the target I'm going to fit on the model, model.fit. And then I'm going to find out that what's the score from this particular model. Once I've done this, you'll find that the score is 1.0. 100% fit. 100% fit. Right? 100% fit we are getting on the training data as I had discussed earlier. Some questions. Okay. So Priyansh is asking that what is random state 42? So Priyansh, what happens is that whenever we are building these models, right? So randomly assigns many different parameters to these models. So whenever we are fixing the random state at a particular value, next time also when you run this particular model, it will run with the same set of parameters. Even if you don't give this random state, it will work pretty fine. No issues. It's just to ensure that, okay, if you're trying to maybe compare multiple models, you should be having the same kind of a model state at every place. Why 42? Again, you can give even any number. You can give 1, 10, whatsoever. I've given 42 out here. You can give any other number. Whatever number you give, you will probably use that random number to do all those model building and splitting. 42 doesn't have any significance out here. You give it 10, you give it 20, whatsoever. But whatever number you fix it, it will remain consistent. Okay. So my model has been fitted and the score on the train data is 100%. But my question to the class that the score on the train data, is it a good indication of how my performance is, or there is something which I need to do? My score on my training is 100%. 100% what I'm getting. Means I've created an excellent model. Yes or no? Answers have come in. So Nisha is saying no, Priyansh is saying no. Okay, so now why, Nisha or Priyansh, why do you think it is no? Why do you think it is no? So see, on the training data, we have got 100% result. It might so happen that the model has overfit. We don't know. The model performance we need to calculate not on the training, but on the validation data. Kaushik is saying too good to be true, right? Nisha is saying could be biased. Yeah, I'll probably take Nisha's answer. It could be a biased result. The result could be biased. right? So yeah. So what I'm doing is on my validation data, x underscore valid, I'm making the model predict on the validation data, and the values are stored in y underscore predict. Right. So by the way, this was a regression problem. So let me use the regression metrics. Right. R2 score, MAC, MAE. These are the various regression metrics. R2 value, mean squared value, mean absolute error. Right. So I have calculated the R2, MAC, and MAE. If I print these values, this is what I'm getting. So my MAE value is 11240, mean absolute error. Mean squared error, remember mean squared error, it squares up the values. 518279, very high value. R square value I'm getting as 0.71. That's what I get. Right? So though my training data had a 100% accuracy, in my validation data, see that the R square value is only 0.71, while for the data it was 100%. If I look into the depth of this decision tree, the depth of this decision tree is 9, is what I'm getting. This is the maximum depth of the decision tree which has been created. So let's do one thing. Let's now visualize this particular decision tree that we have just created. Let's visualize. So for visualization, from sklearn.tree, import this plot tree. Export tree is not required. You can just import this plot tree. I'll show you export tree also. Yeah. Just import this plot tree. And then from matplotlib, from Seaborn, we are importing this library so that we are able to visualize or see this tree in action. That's why this particular libraries, whatever is there, they are being used for the visualization. Let me do the plotting. Taking some time. If you remember, one of the disadvantages of the decision tree was it takes some time into where the tree is. Are you able to make anything out of this tree? Might say that, Professor, yes, we can increase the font. We are able to see, but you can see, I mean, it is such a big, complicated one. Very difficult to do anything with this. Very difficult, right? It's an overfit tree that we have created, right? It's an overfit tree that we have created. Too many levels. Yeah, Nisha, levels. Not very good for my interpretation purpose. Here, there was something called the export tree. If I run that, this is where the business rules it is showing. If the R&D spend is less than equal to 77,528, and then for the R&D spend less than 8410, R&D spend less than 7710, marketing spend is 22586, right? So these are the values, right? That is how the tree has got created. Whatever you saw on the image, we are giving a textual representation of that. Right? From this, you can actually write or create the business rules. Okay. Fine. But again, as most of you agreed with me, that this is probably not the best visualization that we are having. Let's probably see how we can improve this. So again, you are seeing how complicated is this. There is something called a feature importance, where the feature importance of the decision tree is being shown. And then what I can do is I can just put this feature importance into a data frame, which has feature as well as the importance values, which I'm sorting it in the ascending manner. And now if I look into the defined importance values, see, R&D spend has got the maximum importance, 97% the importance, followed by marketing spend, which is only 1.3%. The other ones, the administration, state Florida, state New York, they are negligible, almost negligible. If I plot this, the plotting, see where that R&D spend is actually playing a very important role in determining the profitability of the startup. Whereas marketing spend is also probably some contribution followed by administration. Rest are negligible. Right? Question. So, Nisha, let's do this first part. We will take a break after this. Let's complete this particular part. Okay. That is what we see out here. Okay, so Kaushik has a very important question that in the feature importance, we are not getting California, how to understand for that. So Kaushik, my answer would be if your state Florida and state New York, they had a very high value for the feature importance, then automatically you could have interpreted that California will also be having a high value. Because again, it is derived from the same variable state. If both of these, they had a high importance, that one also probably have had some kind of a importance, right? Okay. That's otherwise what we can do, Kaushik, right? For that also I have a solution. Rather than doing the drop first, I'll just put it like this. Quickly run this. So here this time, my state California also there because I have not dropped the first one. Quickly print a split, creating the model, fitting the model, score. This one will also give 100%. Predicting, looking into the different scores, looking into the MAE, MSC, and R2 values. So this one I'm getting 74% this time. Maximum depth is coming out as 9 once again. And let's come to the visualization part. Okay, so once again, I'm just running this pieces. Plot. The complicated plot will come once again. We don't want that. Again, that's the reality. Exporting. Feature importance. Let's see if something has changed. Okay, so this time R&D spend is coming as 87% contribution. Marketing spend is coming as 1%. And add all these variables which were there. Right? So again, not DataFrame.5 here, 6 are there. So yeah, these are the contribution of all those 6. Right? State Florida has the least, followed by California, New York. Probably it has some kind of importance determine the profitability. Right? Okay. Here is when we are drawing the different feature importance parts. By the way, one thing I'll tell you is that you might ask the professor, how come things have changed compared to the earlier? We are doing a train test split. Train test split, what happens is here we have given 80% of the data for training. So this split is happening randomly, right? So in one particular partition, you might get one particular parts of the data. In other partition, you might get different data. So that's where some of the data, how the data is being partitioned, that might also change how the model is getting built. So last time we had a lot of importance of the R&D spend, very little on the marketing one, but here this time we had some sizable spend impact of the marketing also. Okay. So now what we can do is that we can do this hyperparameter tuning. Okay. Remember, I spoke about this maximum depth of the tree, right? The other things. So let's see what we can do out here is, let's train this tree with several depths. We saw that this tree is having a maximum depth of 9, right? Let's do one thing. This is a function which will create a decision tree on the several levels. So MD is the variable where we are passing on the depth of the tree. We are fitting the training data. We are finding out the training accuracy and the validation accuracy. So let's see how it goes out here. So let me run this particular function, and then let me run this from 1 to 10. Is the depth of the tree I'm running. If I run this for yourself, if I create a tree of depth 1, the validation error is 89%, the training error is 29%, validation error is 89%. If I create a decision tree of depth 2, the training error is 8%, while the validation error is 48%. If I create a decision tree of size 3, right, depth 3, training error is only around 2.3%, while the validation error is 26.35%. With size 4, training error is 0.7%, validation is 34. Size 5, training data is 0.02%, while validation is 0.27. Right? And then you see that from 0.26, it increases, 0.34 comes down, 27, 26, 28, 25, 25. Like this happens. As I said, that it's always better to probably create a shallow tree, which will at least give me some kind of full interpretation on the tree part I'm going to interpret, rather than having a very deep. Right? It's a common pattern that you'll find with all machine learning algorithms. For the training part, as and when you increase the complexity, here the complexity, depth of the tree. As we go on increasing the depth, the training error, it moves on. But for the validation part of the test 1, initially it decreases, then it again starts increasing. That's what we saw here also. Initially decrease, then it started increasing again. Okay. If I plot it, this is what my plot is showing. This is what my plot is showing. At this particular point, you see, for the validation part, the orange is the validation 1, while the blue is the training 1. This blue keeps on decreasing to a particular point. But here, this one, it makes a sharp drop here before it increases. If I put my decision tree at this point, so what is this particular point? What is the depth of the tree at this particular point? Depth of the tree at this particular point? 3. Yes, Dinesh, thank you so much. So at this particular point, it seems that my tree is giving a good performance, right? So what I'll do is, I'll probably right now build a model, right, with a maximum depth of 3 and fit the training data. So let me have a look. So my training data, 97% accuracy is what I'm getting, training data. On the validation data, it is giving me 73% accuracy. See, some of this thing, it changes depending on how the data partition has been put in. So let me just quickly show you. Just let me show. I know that we are probably this thing. If I just release this one, put in this one. So let me collapse this particular part. Visualization, let's not even look into it. Or yeah, we can also look into the visualization part. But this particular part here, we got a tree of maximum depth 8 this time. Right? Visualization, not looking into it. And this time I'm training the tree with several depth. Let's see the results that we got. Let's see the result. So this time I think that my result, the performance has improved. I think I'm getting the best performance at this one. Once again, depth of 3. My training performance is 97%, while the validation performance is 86%. Right? That is what I'm getting out here. Right? See the difference. This is where the lowest difference is there between the training and the validation. And I can show this in your graph also, which we had created. So this is the part. Let's see. Okay. Makes the maximum at this particular point. Depth 3 is where the minimum value is there. So yeah, let me just do this decision 3. Sorry. Yeah. Yeah. 96.96% on the training data, while on the validation, 85.96%. A decent tree I have created. Decent tree I have created. That's how probably you can iteratively go on and check the decision tree performances based on the depth. Right? I think Nisha has been asking us for a break. Let's take a small break. Let's take a small break. Let's come back. It's my clock. Can we come back at 12:40? I think we'll extend a little bit, maybe till 1:15 we'll extend. I hope that's fine with everyone. But let's come back at 12:40. Good with everyone? Good with everyone? Yes, no, maybe. Okay. Let's take this small break. Let's come back, post the break, and continue our learning. Right. So at this point in time, decision tree we have completed. We'll move on to the next piece. Right. I'll show you some more things in this particular part. So in the meantime, everyone keep their orange software open. So let me also project my orange software with you. So let me also project the orange screen. Let's go to this orange part once we come back. Priyansh is asking, coding will come in term end. No, Priyansh, I think in the very first class I've said that. Probably not put you through the coding, but again, in machine learning 3, coding is a mandatory part in your next term. Machine learning 3 coding is mandatory, so you better prepare for the coding part. Better prepare for the coding part in Python. Right? Okay, let's break for the time being. Let's come back exactly at 12:40. Okay, let's come back. Let's come back. Hope everyone has opened the Orange software. So I'll also open the Orange software and share the screen with all of you. It's a very easy to use software, Orange. Let me project my screen with you, and please let me know that once you're able to see my screen. Yeah, is the screen visible? Are you able to see my orange pin? Are you able to see? Yes, no, maybe. Very good. So what we are going to do is the same data set which we did just now. We will work on it. So first I have to get the data into the system. Click on the left hand side which says data. On the left hand side, the particular bar which says data, click on it. In which the CSV file import. Click on the CSV file. Everyone, please be on the same page. Please be on the same page. CSV file import. Can I move ahead, please? Can I move ahead? Once you have this CSV file import, double click it, browse the files, and the 50 startups.csv. This is the file which I'm having. Clicking it, open, and can you see the import options? Cell delimiter, it says comma. Can you see that? Can you see that? Okay. Good. So everyone should get this. Okay. So this is the info. It's showing 50 rows, 5 features, 0 metas. Right? Loading it. Okay. After this, I'm just clicking, just drawing a line from here. So just click on this particular part, move it a little bit, it will draw a line, and click on this one, data info. But double click it, it says there are 50 rows, 5 columns. 50 rows, 5 columns. Of the features, 1 is categorical while 4 is numerical. That's what it says. Right? I hope everyone with me on this. My file has been imported. I can also see that how the file is. If I would like to show the data table, I'm just putting this one, and here you can see this data table. Double click the data table, you'll be able to see all the data. You see all the data which is there. Please do it on your system. Otherwise, what you can also do is that rather than this, just click on the data table which is in the data, second row, first column, and then drag it to a place where you'll be able to see it better. Yeah, here, and then just join. Just click the mouse and join from this to this. And then when I click it, the data table opens up. Right? So all the data you're able to see out here. Very good. Everyone done up to this? Everyone here? Everyone on the same screen? Everyone on the same screen? So Kaushik, I'm getting the answer only from you and Jaya. What about the others? Everyone following? The others, I hope you're following. Okay, I'm assuming that people are following. So after I have this, now what I'll do is I'll actually select the columns which are required for my modeling. So do this, click on this select columns and join this data table with this select column. right? One thing, we have all the data from here going to here. Okay. So or else what I can do is data table is not required out here. I'll just directly join all the data to the select column. Let me just have another for the data table. Yes. What I have data table, and just directly connect the file import to the column. Okay. There's some questions I did not get those questions. Kaushik is saying limited options in data section. Is there any way to bring data select up? Again, I don't know. Maybe you're using some other version. At least in my version, this is how it is. Okay, so let me go to the select column. Double click select column. See, this is what it is right now. Select column. These are the different values which are there. Now, my question to the class: all these values go into the features, or some values should go into the target as well? Should all these values go into the feature, or some of the values should go to the target as well? So Dinesh, correct? Profit should go into the target. So let me do one thing. The profit, just click on the profit, move it from the features, right? So how you do it is, let's say the state, click on state, move it back, click on state, bring it back, right? So profit, move it back from the features to the available variables, and then click on it and put it back to the target variable, right? So right now, my features are R&D spend, administration, marketing spend, state, while the target variable is the profit part. Let me close this one. My select column has also been done, right? I think I am now ready for doing the modeling part. For doing the modeling piece, let's go to the model. Let's create this, click on this tree. And in this tree, I'll just connect my select columns to this tree part. If I double click on this, right? See, you can see these things. Minimum number of instances and leaves. Do not split subsets smaller than 5, right? So minimum sample leaf, minimum sample split, maximum tree depth, all these things are given. So here, limit the maximum tree depth to not 100, but let's say 10 is when I'll reach, right? So yeah, this is what I'm going to do. My decision tree will be created accordingly. And let me do a thing called tree viewer. I'll just do a tree viewer and double click it. Now you will be able to see that how my tree looks like. Right? I'm just reducing the zoom and the width, right? Yeah. Yeah. So you can see the decision tree that has got created in the process. So likewise, the R&D spend is the one which is coming out as the most important one, right? Splits further on the R&D spend, both the cases, right? And then I think in some of the places it will go to the marketing part. But again, having said this, this is pretty cumbersome, as you can understand. We are hardly able to make out much from this. So let's do one thing. Let's prune the tree. So click on the tree once again. Limit the tree depth to, let's say I'm putting it as 3. Click on the tree once again and limit the maximum tree depth to 3. Do that. And now if I go to the tree viewer once again, now I think this is it. This is the tree which has been created with 3 levels. But here, what I see once again is that the R&D spend, that is the particular column, which comes out as still more significant compared to the other one. And this, by the way, the R&D spend itself is a continuous variable. So it is splitting on various particular values of the R&D spend itself. Right? That's what it has. Yep. Not unlimited. 3 levels, right? Related to the parents. Color by default. Color is by default. Yeah. Now the tree of size 3 is what I'm going to see. I'll do one small change from this tree part. Let me not limit the maximum depth. Right? Create tree of size 100, and let's keep the things here. This is where I am right now. Right? Okay, some questions. So Dinesh is asking, why it is splitting only on the R&D values and not on different values? It seems like we're asking the same question again. So here, Dinesh, what's happening is that this R&D value, which you are having out here, that is the most important variable we have seen. And that's a continuous variable. So internally, what happens is that it creates multiple categories for the R&D spend. R&D spend beyond this, R&D spend less than this. So like this, actually it creates multiple categories of the R&D spend. So that's why you see that this is what it is doing. R&D spend. In one case, 77,044 less than that, more than that. And then once again, in the more than part, less than 134,000, more than 134,000. It's finally trying to get more homogeneity into the profit variable. Right? That's why the presentation is like this. Also, another thing is that we have used all the data out here. All the data out here. Right? We had not sampled the data. Had we done some kind of a data sampling? So let's do that thing. From the data, let me just click on data sampler. And rather than going to the select columns, select column, let me just put from the data sampler. And this original data, let me connect to the data sampler. Double click on the data sampler. Sampling type, fixed proportion of data, 80%. Like we had 80% for rows of data we had for the sampling. Do the sampling. I've already said that. And now if I see the final tree which has got created, let's see. No, still it is on R&D spend. Let me do a resampling. Sample data once again. It depends on the kind of partition that's created. Let me open this one up. Still majority it is on the R&D spend node. For at least I'm seeing one thing. Let me make the this thing fixed sample size. Let me use, let's say, 20 sample size. Right? Sample data. Let me see how it happens this time. R&D spend, R&D spend by far is the most important variable. But here you can see that along with R&D spend, state is also coming as one of the variables. State is also coming as one of the variables. If I do the sampling once again, let's say sample data once again, and see this. Yeah, see once again it's R&D spend and state which is coming. Last thing which I'm going to do is data sampler. Do this cross validation. Number of subsets, let's say five subsets. I'll sample data. No, R&D spend by far always comes at the most important one in this particular case. Right? Okay, so Kaushik is asking, can we see the importance of different features here? So Kaushik, one of the things that this particular part is actually not having many this thing possibilities, right? It has limited things, limited part. So let me see. It gives you some kind of I think, yeah, it gives tree viewer. What the tree view is, rank is rank 5. It's not able to out here. Go back to my fixed proportion sample data. This one be on ANOVA. I think ANOVA square Gini decreased get attributes all. Somehow is not showing the amount of data. That's also pretty less. Let me just see once again. All the data goes to here. I hope something will come. Yeah. Now this is what we are seeing. R&D spend is the one which is coming out the top part. Followed by this administration, and see these are the different values. 0.46 as per the relief, R relief, 0.24, 0.37, 0.5%. So here, as we can see out here, that this one R&D spend comes out. But the best rank, these are the 5 best ranked. 5 best ranked. Okay. Right. Okay. Second, for people who were facing some issues in Python, I just thought that I'll show you. So Kaushik is asking what I did. Okay, so Kaushik, what I did was from this tree viewer, from the decision tree, which has got created. So just see this thing. Okay. So here, what we did was from the model we got the tree which we had, and after the tree we put it through something which is called the rank of the variable. So just some rank if we click. So here you see that this is coming in dotted lines. So double click on the dotted lines. Selected data, give all the data to it, not the selected data, but all the data. And then if I hit the rank, what out as the 5 best rank, and this spend comes out as the topmost one. Right? Okay. Again, orange is not a part of the syllabus, but again, I just thought that people who are facing challenges with the Python part can also explore this particular tool, orange. Very easy to learn. It has a very small learning curve. But some of the models, see, it can't much about this part. The data cleaning part. But at least the basic, if your data is clean, the model building part, so models can show you different models are there, right? KNN model is there, decision tree, random forest, right? Linear regression, naive Bayes, neural network, logistic regression, all the different models are already there. All you have to do is just drag, connect, and you're done. Right? Here's the evaluate one. So where you have test and score, prediction, confusion metrics, ROC analysis, different things are there. For unsupervised, you have all these KBs and all those things. So what we'll do is, again, in the unsupervised learning part, but again, that's there in the next term. So yeah, maybe in the unsupervised learning part, when you are learning that, you can actually try to do things like K-means, hierarchical clustering from this orange. Right? Okay, let me close this orange now. Let me go back to the part where I was Okay, what we did, the decision tree, we found that tree of maximum depth 3 was the best, and this was what we got. Now, let me talk about from the tree to the forest, right? This actually comes the ensemble learning part, but again, let me give a brief introduction to this from the tree ensemble learning part. What happens is that a collection of multiple decision tree can help you create something which is called the forest. There, what happens is that the decision tree is not grown fully, but only it's grown partially. So that many partial small decision tree can help grow a forest from where we can get a lot of insight or information about the tree which is there underlying. So let me show you the random forest part. So what happens in a random forest is that you create multiple models, and then based on those multiple models, you try to find out which one is the best one. For example, here is someone who's trying to probably weigh a bull using this particular machine. So one thing which will happen is that you can probably weigh the bull in this particular machine. If this machine is good, it will give out a good result. If this machine is bad, it will give out a bad result. Right? But again, the final value that we will get is based on the biasness of this particular machine which is there. Let's see if we use 1000 machines like this. Right? So each of those 1000 machines will probably give you out some values, and a culmination of those values, the average of those values. The average of those values, you can see out here, average of 8,000 guesses is coming out as 1197, where the actual weight of the ox is 1198. So that's what ensemble learning. You create multiple models. Some of the models are good, some of the models are bad, but just because of the fact you're creating so many different models, when you are averaging the result from the model, it's really going to give you a result which is very close to the best possible result possible. That's a bit of ensemble learning, and a random forest is an example of ensemble learning. So what happens in a random forest is that it works by averaging or combining results of several different decisions possible. That's what happens in the first tree, second tree, third tree, right? And then based on what the tree they are saying, say for example, you are solving a classification problem. In the classification problem, tree 1 is saying it is A, tree 2 is saying it is A, tree N, some of the tree is saying D. We'll go in for the voting of the different predictions, and whichever vote comes out as the maximum, we will take that as the classification result. So here the voting gives out the result as A, class as A. That's what we are getting. For a regression problem, similarly, multiple trees are there, and the result from this multiple small trees we are going to take and average it out, and this average value will be giving the value for my regression tree. Here what I'm going to do is I'm actually going to use a random forest regressor in this particular case. Let me just do from sklearn. I'm just getting the random forest regressor, creating an instance of the model, fitting this particular model on the training data, and scoring the model on the training data. You find that this time it is not 100% accurate. Unlike the decision tree, which was 100% accurate. Why? It had done a fully grown tree and it had become an overfit model. Here we are putting it through a random forest process where small decision trees they have been grown. And what we see on the training data is 98.72% is accurate on the training data. Let's look on the validation data. So remember, in our case, validation data was only giving 86% accuracy, 86%, right, on the validation data. Let me go back if I can see earlier. Yeah, 85.96. That was the validation score. But here, using this random forest, I'm getting 94.79% accuracy on the validation data, a significant improvement from my training data, right? And let me show you how the tree it has created. So this is the one of the first tree that the forest has created. Running this one, so this is the first tree that the forest has created. So here you can see R&D spend is there, marketing spend is also there. Marketing spend is also there. What happens in this random forest is that it creates multiple small trees, as I've said. And whenever it creates these trees, it takes multiple partitions of the data itself. So here you can see that it has taken 27 samples. So this is the model estimator 0. If I take the model estimator 1, find something different. Something different will come out here. So here you'll find that 23 samples have been taken in the model estimator 1. And here also R&D spend, then marketing spend. Right? This is what we are seeing as the significant values. So here, like a decision tree in random forest, also we can get a feature importance. Let me just click on the feature importance. This is the, so again here R&D spend is showing as 90% important, the feature importance. Marketing spend 7%, administration 1.3%, and then followed by the other variables. I plot the feature importance. That is what we are seeing. The king's lion's share is being taken by the R&D spend, followed by marketing spend and administration. Yeah, I hope today at least the step-by-step deduction of the problem, how we are splitting, how we are building the model, that part was clarified to you. I hope so. Right? But I found that students were facing. I hope at least today we were able to solve some part of it. Quickly, I'll take you through the second part where we had to do the model selection. Some part of the piece, I'll just take you through it, and then probably will continue in the next session. Right? So my question before I move ahead is, tell me that how can you probably increase the accuracy of the machine learning model? You have got a machine learning model and you saw that it is probably not giving you the best result. How probably you can improve the accuracy of this machine learning model? Anyone, any thoughts, any idea? Improving the accuracy of the machine learning model. Anyone, any volunteer, please? How you may improve the accuracy of your machine learning model? Please feel free, at least one answer if I can get some from someone. How you may increase the accuracy of your machine learning model? We saw previously, right? We were in decision tree, then we moved to random forest, the accuracy improved. In some of the cases, the data partition we changed, pictures we decreased, increased, right? So yeah, those were some of the clues which were there. Overall, how can we increase the accuracy? Very good. I think both the answers they're correct, yeah. Right? So more training data to the model, splitting data more accurate. Wonderful. So let me project my slide to you. As you rightly said, that add more data to the model. Now, my question to you, Jaya, is that which kind of a data you add? Should you add any kind of data, or again, there's some kind of data you can add? Kajal is saying unbiased data. Okay. Kajal, I think you were already on unmute. So Kajal, can you tell me what do you mean by unbiased data? You're actually on the right track, Kajal. But yeah, what do you mean by unbiased data? Jaya is saying any kind of data. Not really, Jaya. Not really. Not really. That's the wrong answer. Kajal, what do you mean by unbiased data? If you can tell me. Okay, let me tell you. Let's say you are doing a classification problem. And the classification problem, you had two different classes, class A and class B. And when you, and these classes, they are not at the same level. You have 80% of the data for class A, 20% of the data for class B. Now, when you're running the model, you are finding that your model is biased towards class A. Right? The model is biased towards class A. So Kajal is saying collecting important features, not skipping important features. So again, Kajal, if you are skipping important features, which means that you are giving me data which is incomplete, which has missing values. I'm not talking about missing values in the data. Right? You have to give me complete data. You have to give me complete data, but again, data which is probably having less representation in my data set. Right? So if I'm having two classes, let's say A and B, A is having 80% data, B is having 20% data. In that particular case, if I add more data, I should try to add more of class B, because again, that is lesser represented. So my model will get more biased towards the class which is having more representation. Right? That is, add some more data to the model. That's one. Two is treat the outliers and the missing values. If you're having outliers, if you're having missing values, try to treat them properly. Right? Fair enough? And then do some kind of a feature engineering on the data. Ensure that whatever features are there in the data, engineer it properly. Right? You create some new features, drop some of the features which are redundant, right? Which brings us to something called as feature selection. Why we did that feature importance just before this? Because again, when we are creating a model, if we know that all the features are not equally important, there's some features which are very, very important, we can just create models with those features, create much more simpler model and much more interpretable model. So we need to have some kind of a mechanism for doing this feature. By the way, all those things that we have discussed, things like those entropy, things like those index, things like those chi-square values, those are feature selection mechanisms. Can anyone tell me for the regression decision tree, what was the feature selection mechanism? For the regression decision tree, what was the feature selection mechanism? Anyone? For the regression decision tree, what was the feature selection mechanism that we used? For the regression decision tree, what was the feature selection mechanism that we used? We spent a lot of time on it. Please, at least someone give me the answer. Karan is saying correlation. No, not at all. Not at all. We just did it. We just did it, right? For the regression decision tree, what was the feature selection method that we used? So Deepak is saying variance. So Deepak, when you are in the data science space, give precise answer. It's not variance. Reduction in variance. Reduction in the variance was actually the feature selection mechanism that we used, isn't it? So, yeah. Thank you so much. So yeah. And then after that, try out multiple algorithms for decision tree, right? Use the algorithms. Let's say we have used random forest part. Tune that those algorithms, right, to the best possible. And then finally, you can also do a ensemble learning. So these are different ways in which you can improve the accuracy of the machine learning model. What I've seen is that learners, what they will do is they are very impatient these days. And like this Python, Orange, or all the other tools, easiest thing to do is running multiple algorithms. Right? You run 5 different algorithms on the same data, see one of the algorithms coming as the best, and say, okay, this is my best algorithm. But again, as machine learning scientists, what you have to do is probably the other steps also you have to follow. That can I add more data to the model and see if my model becomes better? Can I treat those outliers, machine values, feature engineering, feature selection? Can we do all those things to ensure we come to a very good result? Right? So all those steps, they have to be done. So multiple algorithm, will probably be the last but one step. So after feature selection, you should actually be doing the algorithm tuning part. So can you tell me the decision tree that we did? What was the algorithm tuning part that we did? The algorithm tuning part, anyone? What was the algorithm tuning part that we did for this decision tree? Algorithm tuning, anyone? How did we tune the decision tree so that we can get better results? By pre-pruning, wonderful. Yes, we did actually use the prune decision tree to have a tuned algorithm. Thank you so much. These are some of the ways in which you can improve the accuracy of this machine learning models. So adding more data. Right? The first one, which type of data to add? One, the data should come from the same population. Right? Don't get data from a different kind of population, same population, and ensure that don't add data with outliers. Right? Try to avoid adding data with outliers. Try to add data which are representation of the class, which is not much, which brings to the type of target to add. Target should not unbalance the data. So if you're having already 80% of class A and 20% of class B, no point in adding more of class A to the data. Rather add more of class B so that you can get some kind of a more balanced data. Right? And the other one which you can do, which this one very few people does, because again it's very difficult to do testing for the homogeneity of the data. Homogeneity of the data means that whatever are the characteristics of the data for the training, the same characteristics should be there in the validation as well as the test also. If you have data with completely different kinds of characteristics, not good for you. Okay. Treating missing value at outliers, what you can do missing value is delete the records with missing values. But again, I have told you at the very beginning that sometimes you have so many values. Deletion is sometimes not even an option. So then probably you have to do some kind of a mean, median, mode imputation. Mean, median generally you use for your numeric data, and for categorical data, something like a mode imputation. There are also some kind of a model-based imputation that's possible these days. That's also something that you can try out. And then for the missing values, you can also do this predictive model, which predicts the value of the missing value. So these are some of the things which are being done for values. For the outliers, generally deletion of observation for the outliers, right? Transforming the values to reduce the effect of these outliers. Some of the things that you do for the values and the outliers part. Right? Okay. Feature engineering part, some kind of a variable transformation, changing the scale of the data, changing non-linear data in linear relationships. Those are some of the variable transformation that you can do. Transform the skew distribution to a more even kind of. These are some of the processes that you can use. If the data is very much on the right hand side, use the square root of the cube of the data. If it's left, use basically the square or the cube of the variable. These are some of the ways which you can transform. I'm sorry, skewed distribution. Also, multiple algorithm. Again, I think I have told you that on the same data set, same partition, apply multiple algorithms and see what kind of a results you're getting. And then feature selection, very important. For doing the feature selection, you have the right kind of a domain knowledge about statistics, and doing a data visualization, how a particular feature is affecting target variable. That's also how you can do the feature part. Right? Okay. It's already 1:20. I think let's stop here. Next class, speak on this model selection part and move on to the ensemble method class. Right? Questions before we stop? Questions? Any questions? Any doubts, any concerns before we stop? Questions? Questions? Okay, so Dinesh is asking, for Gini, we can use GI equal Px into 1 minus Px. Yes, definitely use. You can definitely use that. So again, Px into 1 minus Px is basically one class and the complement of this. Yeah, you can use that. The formula which I have shown you, that's actually derived from this Px into 1 minus Px. But definitely you can use that also. No harm. No harm. Just to show you, sorry, just to show you how the other one comes in. Since you raised this, so Px into 1 minus Px. If I open this, this is Px multiplied by Px whole square. Right? If I do this thing, if I do a plus 1 here and minus 1 here, so what I'll do is this particular part is the 1 minus Px whole square part, and this particular part Px minus 1 is basically minus Px bar part. So once again, 1 minus Px bar part will lead me to Px, and this will lead me to the same result. Again, for the sake of the learning, both the results, they are equally valid. Not to worry. Okay, any other question? Any other question that you are having? Please go through the async content before coming to the class. They will set you up for the learning, for the class. Then I think our discussion, our class flow, that will also become much smoother. I've already shared you the Python script. So yeah, please feel free to run this Python script in your computer, and then probably be able to deduce how we got those results. Right? So again, I think I'll take your break now. Right? I'll take your leave. So let's meet again in the next class. Right? I hope you have a nice weekend and very well in the IS that is scheduled in the next week. Fine. All the best, everyone. Take care. Bye-bye. Bye. Have a nice day.